You read the glossy press releases.
Oh, yeah.
They always promise the world. But then you sit down at 2 in the morning, your code is completely broken, you're exhausted.
We have all been there.
You don't want magic in that moment, you just want something that actually works.
Welcome to the Deep Dive. I'm really glad you're here with us. Today, our mission is exploring your sources on xAI's newly announced Grok 4.5.
Thanks for having me. I've been digging through these numbers all week. It's an incredibly fascinating data set.
It really is. So here is our roadmap. We're going to unpack its core specs first.
Right.
Then we'll decode the benchmark reality check. We'll explore the hidden economics of token efficiency.
That part is super interesting.
Yeah. Then we'll look at real-world bug hunts and 3D app generation. Finally, we'll define exactly where Grok 4.5 hits a glass ceiling. We'll compare it to heavyweight rivals like Fable 5, GPT-5.5, and Opus 4.8.
It's a packed journey today. We definitely have a lot of ground to cover.
So Grok is cheap and efficient on paper.
But let's look closely at this first segment. What exactly is Grok 4.5 under the hood? We need to start with the spec check.
Yeah, let's dive into it.
The sources say it was developed directly with Cursor. Cursor is a very popular AI-powered code editor.
Right.
They built this model specifically for software engineering. They deeply optimized it for knowledge work and agent workflows. Agent workflows are multi-step tasks and AI manages entirely on its own.
Right, and that context is crucial here. It isn't just a generic chatbot in a browser.
Yo.
It's designed to act like a highly focused junior developer. It sits natively inside your actual coding environment.
Yeah, that makes a big difference.
Exactly. It isn't trying to write poetry or summarize novels.
Yeah.
It wants to write functions and fix your syntax errors.
The technical specs are pretty staggering to think about. It has a 500,000 token context window.
Wow.
Yeah. A context window is the amount of text the AI can remember at once.
500,000 tokens is a massive cognitive leap. It fundamentally changes how you approach complex coding projects. Well, you aren't just feeding it a single file anymore. You can feed it entire code repositories all at once.
It really is mind-bending. It's like holding an entire library in your short-term memory without dropping a single book.
That is a great way to put it.
And the output speed is around 80 tokens per second.
Yeah, and that sheer speed is absolutely crucial.
Because it keeps you moving.
Right. 80 tokens a second is far faster than human reading speed. It feels almost instantaneous when you are working. You ask a highly complex architectural question. The code just pours onto your screen like water. It keeps you in a state of deep flow.
Let's look at the baseline performance numbers. xAI is claiming some very strong scores across the board. It hits 54 points on the Artificial Analysis Intelligence Index.
That is a solid baseline for general reasoning.
And it scores 76 on the Coding Agent Index.
Those are highly respectable numbers for a specialized model. They really put Grok up there near the frontier models. But the pricing structure is where it gets genuinely interesting.
Exactly. It costs just $2 per million input tokens and $6 per million output tokens.
That is extremely aggressive pricing for this market. They're clearly targeting the daily grind of software development.
Because you don't always need the smartest model.
Exactly. You don't always need a genius-level AI for every task. Sometimes you just need a fast, heavily caffeinated, competent assistant.
2 secs silence. Which raises an important foundational question here. Does raw token speed actually translate to better problem solving or just faster typing?
It's really a mix of both, honestly. I mean, fast typing without logic just creates bad bugs much faster.
Right.
But Grok 4.5 has the baseline intelligence to back it up. The unprecedented speed means you can iterate much faster. You can test a hypothesis, fail, and try again in seconds.
So speed is useless if the underlying logic is flawed. Beat. Moving on.
Exactly right. We need to look much closer at the actual performance data.
We know the on-paper specs are impressive, but how does it actually perform in sterile testing environments? And why does the test setup matter so much?
Benchmarks are notoriously tricky in the AI space. They're basically just highly controlled laboratory experiments.
Right.
They don't always reflect the messy reality of production code.
Let's look at DeepSW 1.0. This is a tough repository-level software engineering test. Grok scored 62% on this benchmark. It was just behind Fable at 66.1%.
Yeah.
And just behind GPT 5.5 at 64.31%.
That is a very tight cluster of top scores. Grok is hanging right there with the absolute heavyweights. It proves the foundational logic is fundamentally sound.
But then we look at the SWE marathon benchmark. Grok actually led the pack on that specific test.
Yeah, that surprised some people.
It had a solid 29% resolution rate. It outright beat Opus 4.8 and Fable.
That is a critical data point for developers to understand. SWE Marathon tests much longer, complex software tasks.
Not just quick edits.
Right. It isn't asking for quick, isolated code edits. It demands sustained attention over a long period of time.
I have to admit something here. I still wrestle with prompt drift myself when trying to manage long automated workflows.
Oh, we all do. Prompt drift is absolutely brutal for productivity.
It really is.
And the AI starts strong, but slowly forgets the main goal over time. Grok, leading the SWE Marathon, suggests it fights off that drift quite well. It stays locked onto the original objective.
It also scored 83.3% on Terminal Bench 2.1.
Mm.
That's almost level with the top-tier premium models, and it scored 64.7% on SWE Bench Pro.
Right.
SWE Bench Pro is a tough benchmark testing AI on real-world software engineering tasks. But there is a cautionary tale hidden in the data.
Ah, yes, the notorious testing harness issue.
Exactly. On Dex SWE 1.1, Data Curve used the Mini Suite agent harness. A testing harness is the software framework delivering the test instructions to the AI.
Right.
Grok's score dropped dramatically to 53%.
Yeah, a huge drop.
Meanwhile, Fable hit 70%, GPT-5.5 hit 67%.
This is exactly why you can't trust a single chart.
So why does the testing harness change the score so drastically?
It comes down to how the model expects to receive instructions. A harness is just the framework delivering the standardized test.
Okay.
If a model was trained on one specific prompt structure, changing the harness breaks its rhythm. Fable and GPT-5.5 are highly generalized intelligence models. They adapt much better to weird, unexpected testing environments.
That makes a lot of sense. Let's talk about the underlying token economics now. This specific detail completely blew my mind.
Yeah, this is wild.
According to XAI, Grok 4.5 averaged about 15,900 output tokens per SWE Bench Pro task.
This shows incredible restraint.
But Opus 4.8 used over 67,000 tokens for the exact same tasks.
That is roughly 4.2 times more tokens consumed.
Why does Opus 4.8 burn through 4 times as many tokens to solve the exact same problem?
Well, Opus naturally tends to think out loud.
Oh, interesting.
Yeah, it generates massive amounts of internal reasoning text before it writes the final code. Grok is a much more direct, utilitarian model. Just skips the monologue and outputs the final solution. This saves you a massive fortune in API costs over a long coding session.
Basically, Grok gets straight to the point instead of rambling. On to real projects.
Yes, exactly. Theoretical benchmarks only take our understanding so far.
Benchmarks are just theory. Let's look at how Grok 4.5 performs when the gloves finally come off. We have fascinating data from actual, messy development environments.
This is where we see its true colors emerge.
The sources mention extensive automated code audits. Grok successfully reviewed massive code bases for hidden security risks.
Right.
It also handled quick GitHub pipeline reviews. A GitHub pipeline is automated scripts that test and deploy your software code.
Though we should note a very important limitation here.
What's that?
The sources don't prove it can handle complex pull request comments entirely on its own yet. A pull request is a formal request to merge new code into a project.
That's a fair point to keep in mind, but the autonomous bug hunting is truly wild. In one personal test, a developer gave Grok a repository with 45 hidden bugs.
That is a total nightmare scenario for any human developer.
Grok successfully fixed 5 of them and found 2 more. It finished the entire process in 16 minutes and 30 seconds.
Wow.
The total compute cost was just $5.82.
Think about the staggering economics of that result.
Yeah.
Hiring a human engineer to hunt down 7 obscure bugs would take hours. It would easily cost hundreds of dollars in labor. Grok did it for the price of a fancy coffee.
Here is where it gets really interesting for visual creators. 3D app generation.
Oh, this is a fantastic, eye-opening example.
One test asked Grok 4.5 to rebuild a 3.js 3D globe dashboard. 3.js is a popular library used to create 3D web graphics. The user provided only one prompt and one reference image.
Just a single image, no other context at all.
2-sec silence. Whoa! Imagine watching a complex 3D glass globe render perfectly on the first try from just one image.
It's visually stunning to watch it happen. The dynamic lighting matched perfectly. The intricate glass panels matched.
Unbelievable.
Yeah, the depth and spacing were almost completely identical to the reference image.
Another prototyping test was even crazier. They used Grok 4.5 to build a playable first-person shooter game. They did it in Grok Build in under an hour. They just ask for a basic game design document and use free web assets.
It's an absolute prototyping monster. But we do need a serious reality check here.
Right. Prototyping is great, but how dangerous is it to push that AI-generated game code straight to production without human review?
It is incredibly dangerous, to be blunt.
Yeah.
These models write highly confident-sounding code. But confident doesn't necessarily mean secure. It doesn't mean the database is scalable.
Right.
You still have to test the gameplay mechanics. You have to carefully review the software architecture. You have to ensure it won't crash under a heavy user load.
Right. Prototypes still need human oversight before going live. Beat sponsor. Welcome back to the Deep Dive. We're exploring the ground-level realities of xAI's Grok 4.5. We've seen its impressive speed. We've seen its prototyping chops. But no AI model is perfectly flawless.
Far from it. They all have distinct blind spots.
Let's explore exactly where Grok 4.5 needs adult supervision.
It really comes down to handling complex orchestration.
The sources highlight a specific shared workflow developed internally at X.
Yeah, this is a great case study.
In this workflow, Grok 4.5 handles all the daily coding and debugging. But it heavily relies on Fable 5 for high-level planning and orchestration, and it relies on GPT-5.6 sockcall for the hardest, most complex coding work.
This represents a profound shift in how we actually use AI.
It clearly struggles with deep thoroughness, right?
Yeah.
Grok is great for incredibly fast implementation, but Fable 5 is needed to review potential weak points. Fable actively looks for missed edge cases. It applies careful, systemic reasoning to the whole project.
Exactly.
Yeah.
Grok is a brilliant sprinter. Fable is a patient chess player.
Beat, listening to you describe this workflow, it almost sounds like managing a construction crew.
Oh, definitely.
Am I off base here, or is Grok essentially the incredibly fast bricklayer? It throws up walls at lightning speed. But Fable 5 is the architect who makes sure the wall is actually straight.
That is a perfect, highly accurate analogy. You definitely don't want the bricklayer designing the foundation blueprints. And you really don't want the master architect laying every single brick. It's a massive waste of their highly specific talents.
Does this mean the dream of one single god model doing everything is dead for now?
I strongly believe so, yes.
Yeah.
The entire industry is rapidly moving toward multi-agent systems. It's simply much more efficient to use specialized models for specialized tasks. One massive, generalized model trying to do everything is just too slow and too expensive.
Specialization is clearly winning over generalization. That brings us to our final showdown.
The underlying economics of these multi-agent workflows.
Understanding Grok's limitations leads us somewhere deeply important. It shows us exactly how smart developers are splitting the workload today.
Right.
They expertly balance Grok with more expensive premium models.
Let's break down the specific model matchups.
First, we have Grok versus Fable 5. Fable is primarily used for high-level design. It provides clear architectural direction and connects sequential steps. Grok happily takes over once requirements are crystal clear and actual implementation begins.
They're highly complementary tools. They aren't direct zero-sum replacements for each other.
Then we have Grok versus GPT-5.5 and Opus 4.8.
Right.
GPT-5.5 is still vastly better for deep systemic reasoning. It is much better at careful, nuanced code review.
But the financial cost factor changes the equation entirely here.
Right. One direct comparison showed an average task cost of just 31 cents for Grok 4.5.
Okay.
But Opus 4.8 Max cost a massive $1.80 for the exact same task.
That is nearly 6 times more expensive for the same output.
But let me push back on this pure cost-saving narrative for a second.
Sure.
Is the 31-cent task really cheaper in the grand scheme? What if you have to spend your own cognitive energy double-checking Grok's work? It inherently lacks GPT 5.5's deep architectural reasoning.
That is the hidden, often ignored tax of cheaper models.
Exactly.
Your engineering time is actual money. If Grok saves you $1 but costs you 20 minutes of frustrating debugging, you absolutely lost money on that exchange.
Where is the tipping point where cheap API costs are outweighed by human debugging time?
It entirely depends on task ambiguity. If the task is perfectly defined with clear boundaries, Grok wins easily.
Right.
If the task is highly vague and requires major assumption making, human debugging time will quickly destroy any API savings.
Yeah.
You absolutely need the premium reasoning models there.
Use Grok for clear blueprints and premium models for ambiguous problems.
Precisely. That is the winning strategy for modern developers.
We've covered a tremendous amount of ground today. It's time for our big idea recap.
If we pull all these intricate threads together, a very clear picture emerges. Grok 4.5 fundamentally changes the daily software coding grind. It offers an unprecedented, highly disruptive balance of pure speed and cost efficiency.
Yeah.
It isn't trying to outthink Fable 5. It isn't trying to beat Opus 4.8 on complex orchestration.
Right.
Instead, it completely dominates the actual implementation phase. It dominates rapid prototyping once the instructions are crystal clear. It is the ultimate, highly efficient blue-collar worker of the AI world.
I really love that specific framing. It is the ultimate blue-collar AI worker.
Yeah.
Thank you for joining us on this deep dive today. I highly encourage you to test out these multi-model workflows in your own projects. See firsthand how the bricklayer and the architect work together.
It's a total game changer for daily coding productivity.
I want to leave you with one final lingering thought to mull over. If AI models are rapidly specializing into distinct roles planners, coders, and reviewers, how long until your main job as a developer is no longer writing code but acting as the HR manager for a team of specialized AI agents?
Yeah.
Out to your own music.